Hi, Pre-calc. So please remember that for this lesson, this first starter page should be uploaded in the starter post. It will count as a classwork grade. Remember that the grading policy changed. Please see the post over the weekend from March 28th to see the changes for the grading policy. But let's look at the mini lesson. So the mini lesson situation is that there's a summer job, you have one, and there's time and a half for overtime. And overtime in general in the US is if you work more than 40 hours a week. So time and a half for overtime means that any overtime hours you work, you get 1.5 times your normal wage. And in this case, the normal hourly wage is $10. We're getting 1.5 times, so that would be $15 an hour. All right, so we want to graph a piecewise function that will let us see this relationship. Now remember, we always want to label the axes. The x-axis for this one will be time, as it usually is. So this is time, and we're measuring it in hours. And then on the y-axis, this will be the pay, measured in dollars. All right, so remember that the wage is $10 an hour. So if you work 0 hours, you're not going to get any money, but it's going to go up at a constant rate after that. So for example, at 10 hours, we're going to get 10 times 10, which is $100. 20 hours, 20 times 10, $200, etc., until we get to $400 for 40 hours. So linear relationship for the first 40 hours. And then what happens after that? Every hour after that, we get $15 an hour. Remember, time and a half. So let's say we're working 50 hours. That means we had the first 40 hours at $10 an hour, and then the next 10 hours at $15 an hour. So if we work 10 hours at $15 an hour, we're getting another $150. So we'd have a dot up here. At 60, we get another $150. So we'd have a dot up here. So let's connect these dots now. All right, first up, our normal hours. Whoops. Here we go. And then our overtime hours. Nope, a little bit off. There we go. Fill that in. All right, so there is our piecewise function. All right, so let's look at the next question after this. Using this graph, evaluate P of 30. So to use the graph to evaluate it, we have to look at 30 hours right here. And we need to see where our function hits when x is 30. And that hits right over there. So we know that P of 30 is equal to $300. And what does this mean? That means if we work 30 hours, we earn $300. All right, let's look at the next question. Write a function that models this graph. All right, so we have to write a piecewise function. And this piecewise function has two separate parts, the regular pay and the overtime pay. So we always start off our piecewise function with an f of x equals and the brackets. And we're going to have two parts for this one. So let's see our first part. The first part, now if you want, you could take 2 points and find your equation using those 2 points. Remember, you learned how to do that a couple of lessons ago. But we happen to know our rate in this one. Now remember, a rate is another name for a slope. A slope is always a rate. What is the rate of pay for this first part of the piecewise function? it's $10 an hour. So 10 is our slope. And then we actually know our y-intercept for this one because here we have a point on the y-axis, and that's at 0. So we know for the first part of this piecewise function, it is 10x, and if you want to, you could write the 0. Now remember, we also need to write the domain. So remember, this first part of the piecewise function goes from 0 to 40. And that's not 40, there's 40. So let's write that domain in. 0 is less than or equal to x is less than or equal to 40. All right, and the next part of our piecewise function, we know it begins at 40, and it can go until whenever. So if you want to, you could write the domain in right now. It's for x is greater than 40. All right, now what was the rate for this second part of the piecewise function? Let me highlight it in a color. There we go. What's the rate for that? Well, remember, our overtime pay is 1.5 times our regular pay, and our regular pay was $10. So this rate is 1.5 times 10, which is $15 an hour. So we know our slope, it's 15. But the thing is, we don't know our y-intercept for this line because this green section does not cross the y-axis. So we need to figure out our y-intercept. And we can do that by choosing a point on the graph. Let's say I'm going to take this endpoint right here. Stop doing that. There we go. 60, 700. All right, so we're going to figure out our y-intercept. So we have a point, 60, 700. We know our slope is 15. So let's figure out our line. We'll use y equals mx plus b. So 700 equals 15 times 60 plus b. 15 times 60 is 900. So we have 700 equals 900 plus b. That means b is negative 200. All right, so we can write our function 15x minus 200. There we go. There is our function. All right, now using this function, we need to evaluate p of 50. So this goes back to your starter where we use a function or equation to evaluate. And to do this, what we do is we simply figure out where in our piecewise function we are going to substitute the 50. Should it be in the first section, so this section, or should we do it in this section? And how do we know? So we should substitute it into the green part of the piecewise function because you can see that we're valuing p of 50. So the first thing for piecewise functions that we have to look at is which domain does 50 belong in? And 50 is when x is greater than 40. So we will use that part of the piecewise function to evaluate p of 50. Sub it into that green part, so 15 times 50 minus 200. 15 times 50 is 750 minus 200, and that's 550. So there is our answer. All right, I'm going to do just a couple of more problems with you. Oops, wrong way. Down in the workshop. I'm going to skip over number 1. And number 2, I will do 2a and 2b with you. Let me zoom in a little. So 2a and 2b. Whoops. All right, so remember, we are evaluating a piecewise function. First thing we need to check is where does the number that we're evaluating, where does it fit into the domain? So in A, we have f of negative 2. That means x is negative 2. So should we be looking at the top part of the piecewise or the bottom part of this piecewise? we should look at the top part because -2 is when x is less than 0. So we will use the top part of the piecewise to evaluate this. And we'll get f of -2 is equal to 2 times -2 minus 1. So that's -4 minus 1, which is -5. All right, 2b. Now we have f of 3. Let me erase these. So now, should we be using the top part of this piecewise or the bottom part of this piecewise? For this, we'll be using the bottom part of this piecewise because 3 is when x is greater than or equal to 0. That's where 3 fits in. So f of 3, let me clean that up. F of 3, we're going to use x squared plus 2, so that's 3 squared plus 2, and that is equal to 11. All right, so you should be able to work through the rest of the packet to evaluate piecewise functions. Please give me an email if you have any questions, and please keep staying safe.